let's start with problem 1. A is correct because this is the equation for the projection onto a vector. And in this case, u equals I, and b is 3, 4, 5. Now, the dot product of these two, because this is really the same thing as I0, J0, K, the dot product is just going to be I3 times 0,4 times 0,5, which is 3I. And the magnitude squared of I is just going to be I square root of I squared, which is still just like I squared, which, because I is just a direction, it's not going to change the magnitude of our vector. So in the end, it's all going to be 3I. So that's why A is correct. B is pretty easy. It says that if u is a vector parallel to vector u, then u dot v is 0. That's actually like the opposite of the case. Actually, u dot v would be 0 if the vectors are orthogonal 90 degrees to each other, not parallel. So that's just wrong. It says here u is 8, 3, negative 3. U's orthogonal resolution would be u equals 2, negative 1, 5, plus 6, 4, negative 8. Well, going back to what I said before, if they're orthogonal, then the dot product of those two is going to have to be 0. Is it? Let's see. Just take the dot product. So that's going to be 12 minus 4 minus 40, not 0. So those vectors are not orthogonal, so that can't be the orthogonal resolution. Finally, it says that if we have 3 vectors in 3D, and u is perpendicular to v, and w is perpendicular to u, then are v and w parallel? Well, in 2D this would be true, but because it's 3D, it's not. So I'm just going to show you with physical objects because I feel like this is easier. So let's just say this is u, this is v, and this is w. This is u, this is v, which is perpendicular to w. But because we're in 3D, I can put, v perpendicular to u, but because we're in 3D, I can put w still perpendicular to u, but also not parallel to v. So that's why D is wrong. And E is wrong because A is true. So moving on to problem 2. First question. If u cross v is 0, then either u has to be 0 or v has to be 0. Actually, not true. If both vectors are headed in the same direction, like this, then their cross product is also going to be 0. B I dot I cross k again is negative I. Now this is actually true because of some of the properties of cross product. So let's just start with the parentheses first. I cross k is always going to be j, because when you cross 2 direction vectors, then you're going to get the third direction vector because the cross product of 2 vectors is orthogonal to both, and j is the only vector orthogonal to both I and k. But then, because this is j, then we get j cross k, which obviously the only other vector we have here is I. And it can also be negative I, because I would simply be the vector going in, like the orthogonal vector going up, and the negative I would be the same vector but downwards. So B is true. If u and v are orthogonal vectors, unit length then the area of the parallelogram for which they form a corner is 1. Now, the area of a parallelogram is the magnitude of the cross product of two vectors. And each vector can be seen as one side of the parallelogram. So if they're both 1, 1 times 1 is still 1. So yeah, that's unit vectors have a magnitude 1, by the way. So 1 times 1 would be 1. 3 vectors are coplanar if their triple scalar product is non-zero. No, that's the wrong way around. They are coplanar if the triple scalar product is 0. And E, none of the above, not true because 2 of them are true.